We are just surrounded by this hidden world of power, right? It's flowing silently through our walls, our devices, everywhere. But have you ever stopped to think what really stands between you and all that energy? Well, in this explainer, we're going to pull back the curtain and uncover the invisible guardians and these super clever systems that are keeping us safe every single day.
Now seriously, think about that for a second. You plug in your phone, you flip a light switch without a second thought. What is actually stopping you from getting a massive electrical shock?
Well, it's not just one thing. It's actually a whole team of hidden devices, and each one has a very specific job. And when you put them all together, they tell this really fascinating story. A story of protection, safety, and yeah, even efficiency.
Okay, so before we can meet the heroes of this electrical story, we've got to understand the villains, right? I mean, you can't build a safe system if you don't know exactly what you're up against.
Basically, every single safety device out there is designed to fight one of these four main threats. First, you've got the classic shock from touching a live wire. Then there's the risk of fire from overheating. You've also got arc flashes, which are like these mini electrical explosions, super dangerous. And of course, just plain old equipment failure. Try to keep these four in your head, because everything we're about to talk about is a direct answer to one of these problems.
All right, so how do we actually fight back against all those dangers? Well, we do it with a whole team of specialized guardians that are built right into our circuits. Let's meet the first one. Okay, first up is the OG, the original protector, the fuse. I like to think of it as making a noble sacrifice. See, when the current gets way too high, that tiny little wire inside it literally melts. It breaks the circuit and stops the flow of electricity. It saves your expensive TV or computer for sure, but it's a one-time deal. Once a fuse blows, that's it. You've got to replace it.
Then we have the modern workhorse, the circuit breaker. This thing is more like a smart sentry. It's always on guard, and if it senses an overload, it doesn't destroy itself. Nope. It just trips a switch. And the huge advantage here? Well, once you figure out what the problem was and fix it, you just flip it back on. No new parts needed. Way more convenient.
And last, but definitely not least, we have the real lifesaver of the group, the RCD, which stands for residual current device. Now this is important. Fuses and circuit breakers, they're mostly there to protect the equipment from too much current. The RCD is different. Its entire job is to protect you. It's looking for tiny, dangerous leaks of electricity, the kind of leak that could travel right through a human body. And when it detects one, it cuts the power in milliseconds. I mean, faster than a blink of an eye. This thing is basically your personal electrical bodyguard.
So you can really see how they have different jobs, right? Fuses and breakers are all about overcurrent. That's just too much power trying to flow at once. Their main job is to protect your gear. But the RCD? It's all about current leaks, electricity going where it's not supposed to, like through you. And that's why a really safe system absolutely needs both. You need something to protect the equipment, and you need something to protect the people.
Okay, so having all the right gadgets is great, but that's really only half the battle. The other half? That comes down to us, to our actions. So let's dive into some of the essential rules for actually working safely around electricity.
Now this list here, this is not just some boring checklist. This is your personal armor. Every single item here is designed to isolate you from the electricity. You've got insulated gloves and tools that create a physical barrier, safety glasses to protect your eyes from those dangerous arc flashes we talked about, and non-conductive shoes to stop your body from becoming an easy path for electricity to get to the ground. Seriously, if you're working on any circuit that could be live, this stuff is absolutely non-negotiable.
All right, listen up, because this next part is absolutely critical. Before you do any work at all, you have to be 100% positive that the power is off. This 5-step process is called safe isolation, and it's designed to completely eliminate any guesswork. Step 1, find the right circuit. 2, switch it off. 3, you physically lock it so nobody can accidentally turn it back on. 4, you put up a warning sign. And 5, and this is probably the most important step of all, you test it. You use a proper voltage tester to prove that it's dead. You never ever assume, you always test.
Okay, so we've covered safety pretty well. But what about performance? I mean, a safe system is fantastic, but a system that's both safe and efficient, well, that saves you energy and it saves you money. So now it's time to figure out how we can measure just how well our circuits are actually working.
And this quote really says it all, doesn't it? You can't manage what you don't measure. It's so true. We can't make our homes or our workplaces more energy efficient if we have no idea where the power is going in the first place. And, maybe more importantly, how much of it is just being wasted. So that means we have to measure it. So just how much energy are we talking about here?
How much can be wasted in an older, maybe not so well-designed system? The answer might actually shock you. It can be as high as 20%. Just let that sink in. 20% of your electricity bill. Poof, vanishing into useless heat before it even does any work for you. That is just pure waste.
And this leaky bucket idea is a perfect way to visualize it. Imagine for every 100 watts of power you pay for, 20 of them just leak right out of the bucket as wasted heat. So when we talk about designing an efficient system, what we're really talking about is plugging those leaks.
All right, so let's put all this knowledge into practice. We're going to take a look at a pretty typical older system and then redesign it using everything we've just talked about. The goal? Peak safety and peak efficiency.
Okay, here's our classic before picture. And now that you know what to look for, you can probably spot the problems right away. First, no RCD protection on the outlets? That's a huge shock hazard. Then you've got these old incandescent lights. They're just massive energy wasters. And look at this, the circuit breakers are too big for the wires they're protecting. That is a massive fire risk, because the wire itself could melt before the breaker even thinks about tripping. And finally, no labels on the panel? That turns finding the right circuit into a dangerous guessing game.
And here's the after. We've tackled every single one of those problems head-on. We install RCDs for user safety. We upgrade to high-efficiency LEDs to plug that big energy leak. We replace the breakers with the correctly rated ones to prevent fires. And we label everything clearly for safe and easy maintenance. This is the goal right here. A system that isn't just powerful, but it's also smart, and most importantly, it's safe.
So, the next time you flip a light switch, maybe you'll think about that incredible system of guardians working silently behind the scenes to protect you. You know, this isn't just abstract theory. This is the invisible science that keeps our entire world running, and running safely. So my question for you is, what's one part of your world you're going to see a little differently now?